right, let's look at our fundamental trig identities. So that by definition, sine theta is y over r. On the unit circle, the radius is 1. So sine theta is just y. And cosecant theta we defined as r over y, and that's the reciprocal of sine. And so we can write cosecant instead of r over y, we can write that as the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. Okay, and then on the unit circle we have, well, tangent is defined as y over x, and since y is sine theta on the unit circle, cosine is x, so tangent we can define instead of y over x, we can write that as sine theta over cosine theta. And likewise, cotangent can be written cosine theta over sine theta. All right, now on the unit circle, of the unit circle is all points x squared plus y squared is equal to the radius squared, is equal to 1. And replacing x with cosine theta, replacing y with sine theta, so we would get cosine theta quantity squared plus sine theta quantity squared is equal to 1. And then there's just a convention, instead of writing the squared on the outside of the parentheses, we can write that square just as a little, it looks like a little 2 between the sine and the theta, but that really means squared, sine theta quantity squared. So that's what's called our first Pythagorean identity. Now if we take that one and divide both sides by sine squared, that will simplify to 1 plus, let's see, cosine squared over sine squared. Cosine over sine, that's cotangent. So that would be cotangent quantity squared. And then 1 over sine, that's our cosecant. So that would be cosecant quantity squared theta. Okay, so there we get our another Pythagorean identity that comes from the original. And then our last one is just if you divide both sides instead by cosine squared, then we would get this other one, tangent squared theta plus 1 equals secant squared theta. So those are our Pythagorean identities. And now we're going to go ahead and use those to solve this problem. Given sine theta is negative 2/5 and cosine theta is negative square root of 21 over 5, find cosecant theta, secant theta, and cotangent theta. Okay, first up, let's find our cosecant theta. And that is 1 over sine theta. And since sine theta is given as negative 2/5, we get 1 divided by negative 2/5. That's the same thing as 1 times the reciprocal, 5 over negative 2. And so that simplifies to negative 5/2. Okay, next up, let's find the secant theta. And that is 1 over cosine theta. And so that would be 1 divided by cosine. Cosine is given as negative square root of 21 over 5. And so that would be the same as 1 times the reciprocal, 5 over negative square root of 21. And so that would give us 5 over, or we'll just make the whole fraction negative square root of 21, but we need to rationalize the denominator, so we'll multiply both by square root of 21, the numerator and the denominator, so we get negative 5 square root of 21 all over 21. Okay, and last we're supposed to find the cotangent theta, and cotangent is cosine over sine. Okay, so we have cosine, which was given as negative square root of 21 all over 5, divided by sine, negative 2/5. Let's clear the complex fraction there, multiply both numerator and denominator by 5, and so we get negative square root of 21 all over 2. In this example, we're given that sine theta is positive. So that happens when our y values are positive. And so that would be either quadrant 1 or quadrant 2. We're given that cosine theta is negative 2/3. Cosine is negative in quadrants 2 and quadrants 3. And those both happen, both of those are negative in quadrant 2. And our goal is to find sine theta and tangent theta. All right, let's go ahead and get started. So we can use the Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. And we don't know sine squared theta yet, but we do know that cosine is negative 2/3. So cosine squared, and then that's equal to 1. So that gives us that sine squared theta plus 4/9 equals 1. We'll subtract 4/9 from both sides, convert 1 to 9/9, and we get that sine squared theta is equal to 5/9. And then taking the square root of both sides, we get that sine theta is equal to either positive or negative square root of 5 over square root of 9, which is 3. We use the fact that we're in quadrant 2. And let's see, in quadrant 2, sine, that's the y, which is positive. So we're going to use the positive square root there. So it's a positive square root of 5 all over 3. And next, we need to find the tangent of theta. Now we know both cosine and sine, so let's go ahead and use that tangent theta is sine theta over cosine theta. We just found that sine theta is square root of 5 over 3. Cosine was given as negative 2/3, and we can simplify that complex fraction by multiplying numerator and denominator by 3, and that gives us square root of 5 all over negative 2. Let's just make our whole fraction negative. So our final answer is negative square root of 5 all over 2. And lastly, we're going to look at even and odd properties of trig functions. So just a reminder, a function is even if f of negative x equals f of x. So for example, if we have our function f of x equals x squared, if you put in the negative x, you would get negative x quantity squared, which is equal to x squared. So that shows us that the opposite, when you plug in a negative, you get the same thing as your original function. Okay, so x squared is what's called an even function. An odd function is where if you plug in a negative, you don't get the same thing, you get the opposite of what you started with. So for example, our function f of x equals 1 over x is odd because if I put in a negative x, I get 1 over negative x, which is the opposite of what I started with. It's a negative 1 over x. So f of negative x is the opposite of the original function. So that would be an odd function. So let's look at these in terms of trig functions. Okay, so if we look at some angle, and we have a point x, y, we have another point with that same reference angle where we have a positive x, negative y. And so x is having to do with the cosine of that angle. So if we put in, let's say that we're doing, I don't know, let's say pi over 4, okay, and negative pi over 4. Cosine of pi over 4 is square root of 2 over 2. Cosine of negative pi over 4 is also square root of 2 over 2. Those are the same thing, okay? So when you put in a negative angle, you're going to get the exact same value as if you put in a positive angle, okay? So cosine is an even function. And it's the only, well, it's reciprocal. Secant is also even, okay? It's the only, those two are the only even functions. All the other trig functions, tangent, sine, and those reciprocals are odd. So sine, so for example, if we're still looking at pi over 4, sine of pi over 4 is square root of 2 over 2, but sine of negative pi over 4 is not the same. It is negative square root of 2 over 2. Okay, so when you put in a negative angle, you're going to get the same, value, but it's going to be negative down there in quadrant 4. Okay, so that means that sine is a odd function. Its reciprocal cosecant is also odd, and tangent is also odd. Okay, those are just helpful for us when we want to simplify a problem. So for example, if I have cosecant of, let's say, negative 1,200 degrees, because cosecant is odd, let's use that odd property. So cosecant of a negative angle is the same thing as the negative cosecant of the positive angle. Okay, so that's the first thing that we can simplify, is using the odd property. Next, let's simplify that 1,200. Let's find a coterminal angle that has the same cosecant value. So 1,200, that's obviously bigger than a full rotation. So let's find out how many full rotations there are by dividing by 360. And we get about 3.3 something. And so we'll subtract those 3 full rotations, and a full rotation is 360. So that gives us the coterminal angle, which is 120. Okay, so from the odd property, we found that we're going to have the negative cosecant of 1,200, but because of coterminal angles, 1,200 and 120 both have the same cosecant value. Okay, and now we pull out our unit circle and find 120 on the unit circle. And that has a negative 1/2 x value, a positive square root of 3 over 2 y value. Okay, and we use the fact that we know cosecant is 1 over sine. Sine is the y value there, and so it would be negative 1 over square root of 3 over 2. 1 divided by a fraction is the same thing as 1 times the reciprocal. So times 2 over square root of 3. Finally, rationalize the denominator by multiplying numerator and denominator by square root of 3. And so we got a final answer of negative 2 square root of 3 all over 3. Okay, and so we used our odd property, then we found a coterminal angle, and then we used our definition of cosecant. We used that reciprocal property, and then we were able to use the unit circle to evaluate sine of 120 and simplify the fraction. Okay, our next example, we need to evaluate tangent of negative 19 pi over 3. Okay, tangent is odd, and so tangent of a negative angle is negative tangent of a positive 19 pi over 3. Okay, so we use the odd property. Okay, next we want to simplify. We're going to get a coterminal angle. 19 pi over 3 is certainly bigger than a full rotation. All right, so this would be 2 pi, which is the same thing as 6 pi over 3. 2 rotations, that would be 4 pi, which is 12 pi over 3. 19 pi is bigger than that. Let's see. That's 3 full rotations. 3 times 2 pi would be 6 pi. And then in terms of thirds, that would be 18 pi over 3. Okay, so it looks like we can subtract 3 full rotations. And in terms of thirds, 3 full rotations is 18 pi over 3. Okay, so our coterminal angle is 18 pi over 3. We'll subtract that from our original angle, and so we get pi over 3. So we went 3 full rotations and we kept going a pi over 3. Okay, so using coterminal angles, negative tangent of 19 pi over 3 is going to have the same value as negative tangent of pi over 3. Okay, and then we pull out our unit circle. We think about that angle pi over 3. That has an x value of positive 1/2, a y value of square root of 3 over 2, and tangent is y over x, so square root of 3 over 2 over 1/2, rationally or simplifying that fraction, that complex fraction, multiply numerator and denominator by 2, we get the tangent of pi over 3 is the same thing as square root of 3, and from the odd property we had that is negative. Okay, again, so we figured out the odd property of tangent, then we found a coterminal angle was pi over 3, so we simplified our 19 pi over 3 to pi over 3, and then we evaluated our trig function to figure out what is tangent of pi over 3 worth, and so then we were able to find our final answer.